Alright, so looking at this statement, says lead is heavier than iron. But is this an accurate statement to make? Let us explore some more. So if we have equal sizes of lead and iron, the lead would weigh more. So when we are comparing equal sizes of substances, what we are really comparing is their density. So instead of saying lead is heavier than iron, we say lead is more dense than iron. Alright, so exactly what is density? Density tells us how much matter is in a specific volume of a substance. And this is usually 1 cm cube or 1 meter cube. The definition of density in science, we define it as the mass per unit volume of a substance. And so here we have our equation. Density is equal to mass divided by volume. In symbols, we have rho is equal to m divided by v. And this here is the Greek symbol we call rho. Alright, so over this side we have our magic triangle, where we see that the density is equal to the mass divided by the volume. If we want to find the mass, we can multiply the density times the volume. And if we want to find the volume, we divide the mass by the density. SI unit of density is a kilogram per cubic meter, written as kgm to the minus 3, but there are other units such as the gram per cubic centimeter, which we write as gcm to the negative 3. Alright, so looking back at our statement, lead is more dense than iron. We have the actual values here, so we see that lead has a density of 11.3 grams per cm cube, while iron has a density of 7.8 grams per cm cube. Alright, so suppose we are given a question that says, what is the mass of a sample of lead which has a volume of 5 cm cube, 5 cubic centimeters? The density of lead is 11.3 grams per cm cube. So we can go over to our magic triangle. Here we see that in order to find mass, we multiply the density times the volume. So mass is equal to density times volume. So we have 11.3 grams per cubic centimeter multiplied by 5 cubic centimeter. And that's going to be equal to 56.5 grams. We have that cancelling that. The answer is 56.5 grams. Finally, we're going to look at the importance of density. We see here density can be used for quality control, where we need to check the purity or the strength of certain substances such as alcohols or acids. And in fact, density measurements were used when argon, the noble gas, was discovered. Density measurements are also important in engineering and architecture, such as in building construction. Engineers want to find out which materials are more suitable. They have to check density measurements, or if they want to make sure that the strength of a particular structure is perfect, then we need to check the density measurement.